Hi, my name is John Geigo, and this video is for my Tech 1010 class, and this is the final for it. We had to choose a technological area or item, and discuss it to the class. That was either that was in the book or that was discussed in class. And so, what we're supposed to do with that is that we're supposed to talk about the modifications or the things that happened in the past 3 years that made it better, that became modified and all things like that. And yes, I'm wet from the rain. Not my fault. It's the rain's fault. So, anyways, what my the item that I'm gonna discuss is drones and how those have been modified over the years. Um, as we know, drones are unmanned aerial vehicles that can be used for recreational activities like taking videos of Provo Canyon and things like that, like every basic person does, or they can be used as in the military for destroying targets and completing missions and things like that. So, one thing that has always interested me is how they fly and how they know where they're going without crashing. And this is one of the things that was talked about, or that I found online. And this is called, and what is, my bad, let me try this again. And how like these drones avoid crashing into things is called collision avoidance. And when I was online, I was on a website called External Feed, and they said that scientists work every day to better the collision avoidance, so that we don't run them into things. So basically, what they said is to combat this risk and to increase the safety of the drone, scientists are working on a collision avoidance system for the drones. So basically, it's still being considered and used at this time. But right now, like they're just bettering it, and it's gonna be great when they finally get it all figured out. Um, another another modification that they made with drones is how it lands. Most like specifically the drones that we use for recreational. Um, Sometimes I guess like if it's windy outside, it's harder for it to gosh, my hair. It's harder for them to land, and so what was installed into them or into some of the drones were LED lights, according to Jacktown online. It said that the precision landing is something that wasn't included initially in the Mavic 2, which is a model. We suspect that they were working on the kinks related to new LED lighting systems on the bottom of the drone. So there were already LED systems that were on the drones to help them land. So with this, they've improved it. They've made it more precise for it to land in the spots that it needs to be. Um, and also another thing that was improved with drones is the air control of them, because sometimes it's hard to fly those things if the air quality is horrible, or if the air control is just terrible. So Michael Patterson from online, who studied physical sciences and engineering and is a licensing associate, had this to say about the improvement and how it helps. He said, like commercial and civil airplanes, one of the main measurements a pilot refers to when flying a drone is the combined airspeed and pressure data. This is also referred to as air data and is measured using a. Oh my gosh, let me try and see what this is supposed to. How's this is supposed to be pronounced? How it is supposed to be pronounced? My gosh, pilot tube. Yeah, I probably butchered that. That is attached to the wings of the aircraft. When an aircraft experiences turbulent conditions, the pilot. Oh, what the heck? The light turned off. The pilot. What the heck? Sorry. The pilot tube that is attached to the wings of the aircraft. Oh my gosh, let me write this again. The pilot tubes provided inaccurate readings because the design relies on smooth airflow and is parallel to the direction of travel. Inaccurate air data can lead to loss of control. So with the air data being controlled or being taken into effect, it helps control the air control of the drones. So that is it. And sorry for all the all the random things that were happening in this. So thank you so much for watching, and I hope you have a great day.